Good day everyone. In this exercise 16 we have two tanks. A at 25 degrees Celsius. Tank A is connected via valve to tank B, where both have a volume of 200 liters. Tank B is evacuated and nothing in here, and tank A contains a mixture, a saturated mixture, where 10% by volume, that means 10% of the 200 liters is liquid and 90% of the volume is vapor. When the valve is opened, temperature remains the same, but only the saturated vapor flowed from A to tank B. What does that mean? That means the quality originally in A has changed, and we need to find this quality change. Also remember, it was given that the final pressure was equal to the initial pressure as well. So what is required to find is the quality of A at state 1, and we need to find the quality of tank A at state 2 when the valve is open. Then we can find the difference between those. But what information we already have? Remember, we have 10% of the 200 liter as liquid, so we have the volume of the original liquid in container in tank A, and we have the volume of the vapor in tank A as well. So if we have the volumes for each, if we can calculate or find the specific volume for each of those as well from the table at this 25 degrees Celsius, then we will be able to find the masses of each. And as you remember, quality is defined as mass of vapor over the total mass. So from table B41 related to the 410A refrigerant at 25 degrees Celsius, you will find that the specific volume for the liquid is 0.00944 meter cube per kilogram, and the specific volume for the vapor is 0.01514 meter cube per kilogram. We can write that the total mass in tank A at state 1 is equal to the vapor at state 1 and the mass of the liquid at state 1, which can be written as the volume of the vapor divided by the specific volume of the vapor plus the volume of the liquid divided by specific volume of the liquid. Now we know that the volume of the vapor is 90% of the total volume, so that is 0.9 of the V total, and the liquid is 0.1 of the total volume. So plugging in the numbers here, this will be 0.9 times 200 liter, which is 0.2 meter cube, divided by 0.01514. This is the vapor specific volume, plus 0.1 times 0.2 meter cube, divided by 0.000944, equals, this is a 11.9 plus 21.19 totaled 33.07 kilogram. So from here we can work out the first quality before the valve is open. So the quality of tank A at state 1 before the valve is open is the mass of the vapor, 11.9, over the total mass. This is 0.36. Now we need to find the quality in tank A after the valve is open. Now we don't have a lot of information anymore at tank A because we already have exhausted all the given in order to find the quality before the valve is open. But what we know that tank B received only the vapor, and the vapor volume already been given because both tank A and B has a volume of 200 liter. So we can write the following as such. We can say that the mass that has moved to tank B after the valve is open is the volume of tank B divided by the specific volume of the vapor state. But we know that since it's only vapor, we already have this value, or we already have this value as well. So this equals to 0.2 meter cube divided by 0.01514 meter cube per kilogram. This equals to the mass of the vapor included in tank B, or the mass that has moved from tank A to B. And since the mass total in A was originally 33.07 kilogram, then this total amount in tank A has lost the amount that moved to tank B, which is the 13.2 kilograms. So the remainder in tank A now is 19.87 kilograms. But how this is going to lead us to calculate the new quality at state 2? Now we know that the quality is the specific volume of tank A at state 2 minus the fluidic specific volume over the difference between the vapor and the fluidic. But what is this value? We already have those. But what is this value? This is the specific volume of tank A at state 2. Any specific volume is defined as the volume over the mass. So what is the volume of state 2 of tank A? And what is the mass of tank A at state 2? Now the volume will not change, 0.2 meter cube, and the mass of tank A at state 2 is this value. This will lead us to the specific volume of tank A at state 2. Using this value in here, we will be able to calculate the new quality. the state 2 quality of tank A is 0.642. So the change in quality in tank A is considerable. So you can calculate the difference, and it's around a 0.282 or 28%. This was simply done by calculating the X quality of state 2 minus the quality of state 1. Or if you would like to calculate it using percentage-wise, then this is around 56%.